Yeah, hello.
Hello.
Yeah, since no one is talking, maybe I can share a few things. In the Allwinner D1 community, where we're working on upstream support, so for mainline Linux, also U-boot and the Orboot bootloader and related projects, we're making quite some progress now. And actually, Samuel Holland, who is pushing the patches to Linux mainline, just found out that there is some special HDMI PHY, and the what's their name again? RV Boards company. They actually have sources for it, which means that we effectively get a fully open source Linux kernel now for it. So including HDMI support, that was just the last missing bit, at least to get a desktop system to work. And I am, as far as well, in Orboot we already have support for loading the entire thing except for the DRAM init. But there was also some work being done to rewrite the assembly dump to C, which now resides in the SPL fork. So SPL is the second program loader, which is effectively the first one in software. So not the boot ROM thing, that is the mask ROM, but the actual code that you put on a flash or SD card or something. So that is also fully open now, residing in Samuel Holland's fork. And I think he's also upstreaming that part. And I'm also going to port that over to Orboot. So yeah, effectively with that, we get a fully open bootstrappable system with a very nice and decent bootloader environment.
Well, that's good to hear. We've been waiting for upstream D1 support for a long time. The cache, non-coherent cache was the big issue for a long time. You need kernel patches.
Right. Yeah, so I have my own fork of Linux where I basically have everything except for the HDMI support. So I'm now going to rebase things at some point. I'm currently on 5.15.5. Yeah, I can't tell exactly if there is still an issue with the cache coherency, but yeah, at least I can say it works. I can boot Linux, I can kexec into another Linux. CPU-D works. So if you're not familiar with CPU, that's coming from Plan 9, and Ron Minnick ported it to Linux at some point. So it's like, essentially it's a bit like SSH, but you bring the files from your own system when you run them on the remote. So, you just implicitly get them mounted into the remote system. We got all of that working already. I made a gist if anyone wants to try that out. On the D1, you would currently have to use the fel mode that is talking to the on-chip bootloader and then provision the image over USB. So it takes like some 30 seconds or something to load. But other than that, it's quite fine. We actually have meeting notes here, like anywhere I can write to.
If there was a host, they could be writing stuff down. But...
Yeah, I see. Okay. Then.
But if you give me info, yeah, if you give me info, I can give it to the Asian guys, and they can add it to their slide deck.
Yeah, so that's the gist. It's a few notes on building and reproducing things. Orboot itself is currently not really described here, but if you just follow the link to the configuration file for building Linux, so we have Linux configuration in Orboot to reproduce everything. That should help so far. But there are also pre-built binaries that you could just run. Yeah, at the same time, it looks like there is lots of people creating boards based on the D1 SoC. So I know of at least 5 now. Well, no, 6. So there is the Nerja, which was like the first and the official one, I would say. Then came Cyped with the Litchi RV, which is essentially a module. So it's like a compute module thing. And they made 2 carrier boards for it. One of them is the, do I have it here? Not right now. One is the Litchi RV dock. So that's really just a tiny thing, similar to the Raspberry Pi, the like half-size thing, really compact and small. And then there is another board which is essentially a touch panel for home automation, like you tap on things to, I don't know, turn on your AC or something. That's like, I don't know, this size, like 8 by 8 centimeters or something. Then there is a board by Dongshan Pi. I don't know if you know them. They also made a few ARM boards based on Sigma Star SoCs, but they also made one based on the Allwinner SoC. And now there is another one by Mango Pi. I'm not sure if that's already available outside of China currently. So I think it's, yeah, at least on Taobao. I can order from it to Europe here. And then somebody from the Netherlands made another board, also a carrier board for the Litchi RV module, which is, essentially also just a larger breakout board, but it's also getting quite nice. And then there is the D1S, the yeah, almost like the D1 SoC, but it's got some built-in RAM. So I think it's like 64 megabytes in the package. And that is found on also a few other boards, one by Mango Pi. Then there was one like some small, I don't know, Kickstarter-like campaign or some other platform, I don't recall. And some company picked it up, I think, and they're offering it on AliExpress, but I forgot the name. Yeah, so it's really getting quite some traction, I think.
Yeah, there's a lot of efforts in China focused around RISC-V, and they want a RISC-V cell phone, Android-based. So they're doing a lot of software development towards that.
Yeah, they were quite eager. They announced it to ship like somewhere this year. I mean, it sounds like a bit of an overcommitment. But yeah, there is a lot going on.
These boards that you are mentioned, what chip do they have?
The D1.
It's the Allwinner
D1.
Okay. Based on an Alibaba T-head C906 core.
Yep.
It's single core.
Yep.
1 gigahertz, so it's not very fast, but it works.
Yeah, it's a single 64-bit core, but it's okay. I mean, for prototyping and development, it's just fine. And these Litchi RV modules, they're quite cheap. I think like $20 or something.
Well, I'm a GCC developer, and it takes me like 3 days to do a GCC bootstrap on it. So,
okay, it's not meant for that. Let's put it that way. Yeah, I just cross-compile things mostly because as long as we don't have the fast and powerful machines, I think it makes a bit more sense currently. But it's good to test things out that they are running also. So when we have the faster machines, we can just use them right away. Yeah. Interesting. I think there is also some effort on LLVM and Clang. I read something in the RISC-V Slack community.
Yes, well, Android uses LLVM as its primary compiler. So the Chinese, they've been doing a lot of work, Android and LLVM. I'm a GCC developer. I don't follow the LLVM stuff much, but there is an active LLVM community doing development work.
Cool. No. I also heard there is a bunch of additional cores in development. So there is this one, they already had the second iteration now. That was from the, what was the name again? The Shangshan project.
Okay.
I think it's some high performance stuff, but I can't really tell because it's only So I'm a software engineer and mostly working actually on the web, but I sometimes also do some firmware hackery. But yeah, the hardware description stuff is really, not my cup of tea.
Yeah. So Star 5 will be coming out with a second core, better than their original one. And Alibaba, T-Head are apparently working on new cores. And the Chinese Academy of Sciences, that's the one you referred to. That's more of an academic project. I don't know how real that is. I don't know if they'll be building chips and selling them.
Okay.
But at least they have a design that you can put on an FPGA.
Yeah.
And Intel is coming out with Horse Creek. They're saying second half of 2020 now. That'll be a Sci5 P550 core on the Intel 4 process. So that should be interesting.
I think I read something, it could be along the performance level of Skylake or something. Or maybe I'm confusing it with something else.
I don't know if we're quite up to Skylake performance yet, but certainly it should be a lot faster than the existing Sci5 parts, Unleashed, Unmatched.
Yeah. I actually signed up for that developer support project thing from RISC-V Foundation, and maybe I will get a board within about a month. One of the Star 5, whatever it was called, something else 5. I'm losing track with all the 5s.
I think there's a Vision 5.
Yeah, right, Vision 5. Yep. That one.
Well, I'm completely new to this area, but I'm trying to learn and looking for some way to contribute. Have you any tips on how to proceed, how to start?
But where are you coming from? Let's put it that way.
I'm sitting in Sweden. Or do you mean?
I don't mean your location. I mean, like,
okay.
What's your field of expertise currently?
Okay. Well, I'm been working professional with the FPGAs, and the last 10 years more like low-level C embedded programming. So I think it's I'm not that familiar with the high-level Linux kernel. It's more like the low-level hardware, close to hardware. So I'm currently studying the specification and thinking about how to maybe try to get a core running in an FPGA board that I have.
I guess you might have seen was it Serve, SERV? I think it's like, the tiniest RISC-V core in a sense or something. By Olof Kinsven. This one here.
Oh, sorry. I thought you were going to mention Swerve. Western Digital has a Swerve. That's a different one.
They put a W for Western Digital somewhere in that. I don't know. I've heard about it, but I've not yet looked into it. It sounds very close to Serve. Yeah, that would be this one here.
Oh, is this the really tiny but slow core? I think I read about it. Bit serial.
So the RISC-V website has a list of boards, socks, cores. Yeah, Jan wants to talk about Go LLVM.
Yeah, right. Hey, Jan, nice to meet you. technology. Hi.
Wanted to ask about then some maybe an option to share about the initiative for putting the compiler. It has sort of like a bridge between the Golang frontend, which is the same as used by trivial GCC oriented distribution of Go, and LLVM's backend. There is a bridge, and basically this project was tested on x86_64 architecture. It was somewhat tested on ARM, but doesn't have some split stack support, and it has some issues on the compiler since it's typically used Gold. It has issues on the linker side because LD linker used to be available. Gold is available, but Gold doesn't have a RISC-V port, so there is a suggestion to use a linker called mold, which seemed to be actively supported and used to be relatively fast, so it could be also benchmarked. So basically, it's so mold could be used as a linker. It seems to be ported to RISC-V itself, and it might be reasonable to patch some CMake rules for CMake. And there would be some suggestions on supporting the calling convention for RISC-V. So the project uses LLVM's calling conventions, which could be found within the well-known namespace for LLVM, but I don't see that's RISC-V like C++ calling convention for 64-bit Linux, for instance, on x86, but is found in the namespace, but calling conventions of RISC-V is not in the same namespace. So different sources in LLVM refer different calling conventions on various architectures. So there is I would say there is a request on some mentorship on this side about the Golang calling convention for C++, and probably that's it. So it's about calling convention engineering stuff, and somewhat about supporting mold linker, and generally enabling CMake related rules on RISC-V. So it's also additionally, as for the DevOps side of the story, it might be about running the compiling it and run inside the VM. It might be a Docker container. You could also use this result in LLVM-GOG compiler inside the VM, or you can run this inside a container and possibly run like something microservices or function as a service facilities, but I can't tell that is more about running like microservices or something like that. I didn't test that personally. I was more testing that on a VM and was able to launch various applications in Golang, eventually including UI and some background services and something for the monoliths mainly, but also static libraries and shared libraries could be compiled. Executables could be compiled on link. But the front end for Go is basically the same as for, as you might find in the GCC-oriented distribution, but the distribution also has an alternative calling convention, a special linker for the LD, to enable linking and so on and so forth. So gradually significant differences compared to trivial Go distribution. So like that. So I can probably try to ask some questions as far as able to understand about the project, but I'm not actually maintaining the project. So 10 Macintosh from Google maintains that, and there are some new committers which I'm not familiar with, but they are contributing so far. So.
Okay, well, we have a GNU toolchain developer here and 2 low-level embedded programmers. So this is maybe not the right audience for interesting questions about Go LLVM.
I sometimes write something in Go, but I don't know anything about the compiler underneath. I'm just happy when it compiles my code. Yeah. I know I just opened the Google source page that you linked here. I can see then Macintosh, the name, but yeah, I don't know. To be honest, I also just understood a very small fraction of what you just said. Like, yeah, I'm really not involved in that field very much. So yeah. I know that calling conventions exist. I don't know what the specific differences are. I also know that different linkers exist, but I don't really know why one works over the other or why they would behave different for whatever reasons. Yeah, I'm sorry.
Well, mold is a new linker, the modern linker, I think it stands for.
Yeah. Does it support like multiple other tool chains? Like,
it's very new, but I know some support was recently added to GCC to support it.
Yeah, there is some there seems to be some effort for GCC 12, but it's not yet the latest distributed versions. It seems to be which you can find as in the latest build from source, but I can't find GCC 12 on Linux packages on latest Ubuntu, for instance, anywhere. So you have to build it probably by hand and test its compatibility options. As far as was, but it just comes from the explanation on GitHub, but it's not that I tested that on myself, but probably I might try to do that maybe via using GitHub Actions and probably by cross compilation attempts as one case. Another, but still have to be launched somewhere inside on RISC-V under QEMU, on maybe on some hardware, PGA board or some ASIC chips on Linux, I guess. But not that I tried with GCC. So basically the project is LLVM related, so consider a lot of usage would be for Clang. So it's just tested with GCC just for compatibility reasons, in sense of that you compile it, that LLVM compiler itself, linking everything you need, all those executables, tools, and so on. And then it's called to compile the standard library and so on and so forth for Golang itself. So basically, you can try to build LLVM and the bridge and the actual compiler and the whole stuff with GCC, but it would assume that the calling the LLVM compiler for Golang, it will itself will call LLVM related Clang. So Clang is a requirement itself for the compiler, which has sense, but GCC just to like add some compatibility for like compilation purposes, just to compile the compiler, the LLVM compiler for Golang itself. and once it's compiled, it's gonna invoke a Clang, which have to be pre-installed as a normal installation for Clang itself on that machine where you are compiling. So this is just for general understanding. So it's not about sticking to GCC in any form at that sense and at that stage. It's still like Clang oriented project. So you should just consider that it's about it's limited on towards as far as Clang supports RISC-V. On Linux, so like consider those limitations ahead of this discussion. So you wouldn't be able to compile Go executables, shared libraries, those code in Go like executables, shared libraries, and static libraries. Not just as far as Clang on RISC-V would allow you. So consider that this might be something under QEMU, for instance, so it might be on a board. There is a Linux and there is a pre-installed Clang running itself on RISC-V, and it's able to compile something, and you can get some execute your machine code on the output, and the executable static library, shared library, you can use it. In some cases, you might try cross-compilation, but as you can see, there is nothing in the documentation about cross-compiling, but that is another direction, which would probably have sense because of the limitation of RISC-V hardware, a sense of performance. A lot of stuff would still have to be cross-compiled. So assume this is a lot about cross-compiling LLVM on an x86 machine, or it may be an on ARM server, which would cross-compile into RISC on behalf of RISC-V. And then you got that executable LLVM-word compiler, and you can use it on RISC-V. Like this is also an option, and this is probably another request, but this is clearly DevOps. So there would be attempts on this side, and a lot of question would be asked, and some guidance would be required as well.
Well, we don't have any LLVM developers here, so we probably can't do much to help you.
I can't really help you either, I'm sorry. I also wouldn't really know whom to talk to or something.
There is a RISC-V LLVM group that meets every other week. At least they used to. I don't know if they're still doing it.
Do you have a link to that?
I have one from January. Let's see. It's a January email. I don't know if they're still having the meetings. I've never attended these. I'm a GNU developer. I don't follow the LLVM stuff.
No.
But
so this meeting, it seems to be quite regular when I looked at the calendar. Was
You
it
mean the
Henrik?
LLVM developers?
No, I mean this
Did we-
meeting we are having now. The open
Yeah.
hour.
This meeting is twice a month, one in a time zone convenient for Europe and one in a time zone convenient for East Asia.
Okay.
And the East Asia / China meeting usually has several dozen people attend. They have good attendance. The European meeting tends to have poor attendance.
We're sleeping in Europe. We're, you know,
Yeah, the Asian
hesitant.
meeting is probably like 3, 4 in the morning your time. It would not be convenient.
So it's not the European also attending the Asian meeting.
Well, all the action is for RISC-V. A lot of the action is in Asia right now, because the Chinese government is sponsoring a lot of RISC-V projects. The Indian government is sponsoring RISC-V projects. They want to have their own ISAs or CPUs, cores, their own chips and boards and stuff, so that they're not dependent on the Western world for stuff.
Okay. Mm-hmm.
It's funny because we're discussing lots of these things in Europe. Everyone says, oh, we totally depend on the US and we should also be self-sovereign and so on. But nobody is funding or doing anything.
Well, there is a European Processor Initiative, EPI.
Yeah, being quite silent, to be honest. I've never seen anything but a few articles which were really like, you know, teasers.
They did fab a chip, a prototype chip.
I've only read a few articles, but that's it. And that was from themselves. So yeah, I've never seen anything. But I have a few Chinese chips here in my hands. So yeah, that's what I'm saying.
Well, some of the guys in Barcelona Supercomputing Center have been active in the vector specification development. And they are working on LLVM, writing patches, contributing to LLVM. And they're designing their own RISC-V core with vector.
Interesting.
And they did fab a chip, although it has a draft of the vector extension, so it's not compatible with the officially approved vector extension.
Yeah, sure. So yeah, that's also true for the D1. I think they had something like best effort thing. And they have their own compiler changes there for some things. Yeah.
But the topic for this meeting is it quite open, free discussion, like we're having now, or?
Yes, it's just the three of us. We can talk about whatever you want to talk about.
Yeah. Actually, I had one question when I was reading the specification. You can see here if I can share it now. Couldn't do that. Is it only text that you can put in the chat?
Notes with the destination of X0 must erase any exceptions.
I'm a bit confused what they mean with must still raise any exception and cause any other. I don't really follow that sentence.
Well, if you're accessing memory that doesn't exist, there's going to be some kind of exception generated.
Yes, but they are talking about load with the destination of X0, and X0 is the always zero value register. So it probably wouldn't make any sense. You cannot change that value. So it would to me make more sense if it would say X must still and must not raise any exception, must not raise any exception and cause any other side effects.
That's probably harder to implement in hardware because you're going to send a load off to the memory processing unit, and it doesn't care where the result goes. It's just going to do the regular memory processing, which is going to generate errors if you have unaligned address or accessing memory that doesn't exist, etc.
Okay, so they're more talking about that if you're accessing the memory incorrectly.
Yeah, those are the only exceptions that matter here.
Okay. But if you actually access valid memory and try to put the value in X0,
there should be no.
That would be fine.
Yeah, there should be no exception in that case, and the result is just thrown away.
Because I think that's quite nice to have that option, because sometimes you're only interested to make a read, but you're not interested in the value. And in that case, you don't need to club any register for a value that you don't want to have.
Okay. So yeah, I've only been to this meeting here twice, I think, or maybe just once. I'm not even sure. Like once in November and maybe a second time in December. And Jim, you're saying that the Asia-friendly meeting is a bit more crowded. How's it with like general overall progress? Is there like some interesting milestones happening currently?
Well, I tend to focus on the GNU toolchain stuff, but
Sure.
The Chinese, yeah, they're working on new processors. They're working on the Android port, finishing it up, and various other things that Android needs. They have their own distro, Open Euler, which is China-based.
I think I've heard about that. I wasn't pretty
at
sure if that was a distro.
Euler is how I pronounce it. I'm not sure how you would pronounce it, but
yeah, I mean, you could also say Euler. I would understand you,
Euler?
but I would
Okay.
also confuse it with the end user license agreement. Oh, I see. It comes from Huawei. Yeah, so Euler is actually also the German European pronunciation. Interesting. Okay, so there is like an open community edition and some enterprise thing, from what I understand.
It's a full Linux distro.
To be honest, so I'm also involved in, for example, the Linux boot project. To me, a Linux distro is very much a kernel with a single binary. That's already a distro to me. Because that's effectively all I need for a user land. But yeah, that's also why I'm curious, like, you know, what is the distro based on? besides the kernel? Do you happen to know that?
Open Euler. But Open Euler is their own Chinese distro. I don't think it's based on any other distro, at least not that I know of. And they've also been working on browsers and JITs.
Oh, I see.
Over in China. So stuff like SpiderMonkey. I forget all the names. I don't follow that stuff, but you know, they want a full RISC-V distro, so they need browsers and JITs.
Yeah, effectively, that is what makes a desktop system anyway, right? A browser. And you need the JIT for the browser itself, because it's the application platform running it.
All I need is an external window myself, but yeah, browser for the consumer market, you need the browser.
Yeah. Yeah. I'm working a lot with Plan 9 people, so for us it would be draw term and the CPU server.
Yeah, I know the movie better than I know the OS.
Yeah, quite interesting. Thank you. I guess I have more to look at. It sort of never ends. Everyone makes their own distro, their own userland, their own whatever.
Well, all the popular distros are Western based, either in the US or Europe. So they just want their own distro over in China.
Yeah, makes sense. Yeah, that's the part that is always forgotten a bit when we talk about open source stuff, right? So the sources are for everyone to access, everyone may contribute, but the ownership is still in very few people's hands.
Sir, it's a 32-bit RISC-V.
Sorry?
Well, I started a movie here on the server core.
Sure. Okay, I see. Open Euler is RPM based. I'm just browsing the repo and, so not the sources of Open Euler, but, the repo for packages. Like this thing here, it's interesting though. So that one is for x86. There is also AR64, but no RISC-V just yet.
They talk about it in the meetings. I would expect there to be a RISC-V port. Maybe it's just on a different server.
Yeah. I also see 2.8 only has AR64. There is no 2.6, no 2.7 in the mirror here. Yeah, I don't know, maybe it's still a bit in its infancy. And there is some Open Atom Foundation behind it, which I've never heard of either. Interesting.
It's probably another Chinese organization.
Quite surely so, yeah. At least there are Chinese characters in the logo mark. So
Yes.
okay, so they're on Git, but there is also a mirror on GitHub, which is faster for us here to load at least. Ah, and I see there is also something on RISC-V there. Looks like a collection of postscripts.
Their website is very slow to open for me.
Yeah.
Daniel, do you have any links to the boards that you talked about in the beginning?
Sure. Sure. So the first one, the Nerja, are you seeking to buy one, or would you like to look at the product page?
Yeah, buy one would be interesting, but also I think both.
Yeah, so RV Boards is selling it, that one here. It's like 130 euros something for the basic thing. Oh, no, that's the upgrade pack. Oh, wow. The full thing is currently 344, but that's like, you know, with like a lot of accessories. You can also get it for much less, I think. Let me find it.
Is that Raspberry Pi size or similar?
Yeah, it's exactly the same form factor, and also the holds, they are also compatible. So if you have like, you know, something like this here, you know, there are these things where you can just layer lots of them on top of each other.
Yeah.
Yeah, they would just perfectly fit in there. So here is another one, and that's much cheaper. And the link is about to follow. Yeah, I'm sitting in Germany, so all the links start with DE. I'm sorry. But I think it's really just for translation. Just change it for SE or whatever.
The site shows the price in Swedish crowns anyway.
Oh, yeah, right, right. You haven't adopted the euro. That's right. And just changing it to SE doesn't even resolve, as I see. Okay. Links and internationalization. Never works. So yeah, the module, the Litchi RV, is this one. That is the one for 20 euros, or I don't know, is it like 10 to 1 from Svensk krona to euro, I think, something?
200, 204.
Oh, okay.
Yes, 10 to 1, yes.
Yeah. And then the touch panel board is this one. They call it EGRV RV86 panel. I think 86 is for 8.6 centimeters, so that's size. And I have all of these three. And today I just ordered another one, the Dongshan Pi.
Okay.
Oh, right. Yeah, and I forgot one of the boards, which is also based on a compute module like, which is actually compatible with the Raspberry Pi 3 compute module. And that's also featured in the article here. And I think I might be able to also find the website selling it. It's open hardware, by the way, so you can also get the schematics and everything here.
Okay.
If I'm not mistaken. At least there is a ton of stuff in the repo. Oh, wow. And here is a Swedish website for you. I didn't know about Linux.se.
Perfect.
Okay, that does not resolve to something on that module. I just found the website randomly when searching for it. I guess it's somewhere among their articles.
Mm-hmm. Yeah, there's a lot of things to go through here.
Yeah. Okay. Who is Geisler and who is, or what is the Noel RISC-V?
They're the company that produced the Leon Spark chip. And now they have a Noel RISC-V part.
Okay.
It's I guess it's Cobham Geisler. Geisler.
Interesting.
And they have some hardened chips for space applications, I believe. And There's also IAR systems. They produce compilers. They have a RISC-V port, and they're active in some of the RISC-V meetings.
Interesting. Okay, and so you can also find the other modules I talked about, and also the Dongshan Pi board on this platform, Analog Lam. I haven't heard about them until today, to be honest. So yeah, that might be a constraint to some people. So the most of the D1 boards come with 512 megabytes of RAM. The Nerja, not the Dongshan Nerja, but the Allwinner Nerja has 1 gigabyte of RAM. If you have a very, very steady hand and you're into BGA soldering, you could also swap it out for 2 gigabytes. But yeah, somebody has done that actually.
Well, we have some equipment at my work for that.
I don't mind too much. I don't need that much.
I spend most of my development in an environment where I have 20K byte of RAM. It's a very tiny M0 system.
Okay. See. Now, when I'm developing for the web, that doesn't work. I need all the gigabytes that Chrome can get.
Yeah.
I need enough for a GCC bootstrap.
Yep.
So a few gigabytes. Yep.
It's also funny enough when you compile Chrome from source 0. So I don't know. You will need at least like 4. No, it was actually changed to more than 4 gigabytes of RAM. Could be 12 even nowadays. You never know.
Yeah, I've heard it's getting hard to build the browsers on 32-bit machines.
Yeah. So it's essentially like, you know, your hardware is very nice, and then on top of that is your firmware. It should be effectively very small. Then comes your kernel, you know, which is really just the runtime for your web browser, and then comes your web browser.
Enormous thing.
And that is very much Chrome OS now. Yeah. Right. Yeah, it's been nice. Sorry?
I've seen before that in Zoom you can download the chat messages.
Could be.
I don't find it at the moment.
I would just, I don't know, Control A, Control C.
Sounds reasonable. No, doesn't work.
For me, it works. I mean, I'm also marking another few words, but I don't mind. Or you can just mark the entire chat and copy that.
I'm running the Linux client, so maybe it's different.
Yeah, I'm in the web browser. Let me do the following. I will copy this. Okay. Because of how they render things, you can't do that. Because they only keep the fraction that you actually need to have in the view. So you can't mark everything, you know. What you mark before gets lost when you scroll. I will create a gist on GitHub. And I will paste everything there. I will now copy page by page. Page 1.
Somebody's recording this, so maybe that's...
I guess it's happening automatically or something.
Probably automatic.
Well, I think I have all the links as a tab in my browser.
Okay.
So maybe that's enough. Yeah. It was nice talking to you. I need to go
likewise.
grab some dinner. So
Now we'll see if I can also make it again next time.
Yeah.
Right.
Okay. Goodbye. Thank you.
Bye.
Bye.
So I'm also dropping out. Take care.
Yeah. Bye.
Bye.